Now, unfortunately, I really don't have enough space in order to do this problem, but first I'm going to at least start out here. My matrix is going to be 1, 2, 1, negative 1, 0, 5, 2, 1, 1, 4, 0, negative 20. So the first thing that I do as I plan my action out, I go down the main diagonal, and that says what I want, well, color, is a 0 here, a 0 here, and a 0 here. So I want zeros in those three positions. Now, how is that going to happen? Well, it's going to happen by taking this guy is going to kill these two, so that's going to be my next matrix. So I'm going to take a negative 2 times row 1, add it to row 2 to give me a new row 2 that puts a 0 in that position. A negative 1 times row 1, add it to row 3, that gives me my new row 3, that puts a 0 in that position. So now I'm going to move to paper where I've got enough space to do this. I apologize. So here we go. I'm going to create a new matrix. Row 1 is going to stay the same. I'm going to put a new row 2 and a new row 3. I'm going to create a new row 2 by taking negative 2 times row 1, adding it to row 2 to give me a 0 in that position. So negative 2 times row 1, added to row 2, gives me my new row 2. So negative 2 is going to give me a negative 2. Negative 2 gives me a positive 2. Negative 2 gives me a negative 4. Negative 2 gives me a negative 8. And added to row 2, which is 2, 0, 1, 0. That gives me a 0, 2, negative 4, negative 8. Now I'm going to create a new row 3 by taking, it says, negative 1 times row 1, adding it to row 3. So negative 1 times row 1, adding it to row 3 is going to give me my new row 3. I have to move this up. So negative 1 times row 1, negative 1, negative 1, positive 1, negative 1, negative 2, negative 1, negative 4, added to row 3, which is all the way up here, which is 1, 5, 1, negative 20. So 151, negative 20 gives me a 0, a 6, a negative 1, and a negative 24. And now I look again, and here's my main diagonal. I need a 0 in that position, and this is the guy that's going to give it to me. So that means I need another new matrix where the first row stays the same. The second row stays the same. And the third row is the one that's going to change. So how am I going to do that? Well, I need to get rid of a 6. So if I take negative 3 times 2, that gives me a negative 6. Positive 6, negative 6 is 0. So I'm going to take negative 3, multiply it times row 2, add it to row 3. That's going to give me my new row 3. So, negative 3 times row 2, add it to row 3, my new row 3. Negative 3 times row 2 gives me a 0, a negative 6, negative 3 times negative 4, positive 12. Negative 3 times negative 8 is positive 24. And I'm going to add it to the existing row 3, which is 0, 6, negative 1, and negative 24. And I think I've got an error. Right here. This should be a negative 3. So this should be a negative 3. This should be a negative 3. Fortunately, it's not going to make any difference, but I'm lucky that way. And that means that if that is a negative 3, this should be a positive 9. Because I'm multiplying by negative 3. Negative 3 times negative 3 is positive. Everybody else is okay. So this is 0, 0, 8, 0. That's why the fact I had an error here wouldn't make a difference, because z is going to be 0. So now I'm going to work backwards. This says that x minus y plus z equals 4. 2y minus 3z equals negative 8. 8z equals 0. That means that z is 0 divided by 8, or z is 0, so I have z. 2y minus 3 times z equals negative 8. 2y equals negative 8, or y is negative 4. X minus y, which is negative 4, plus z, which is 0, equals 4. X plus 4 equals 4. X equals 0. So we have x, y, and z, or you can write it as a coordinate point, x, y, z. X is 0, y is negative 4, z is 0. So that problem did take a full page. Moving to this one, this is one just like you're in your packet. I want to find a function, y equals ax squared plus bx plus c. Find a, b, and c, where these are the coordinate points. So I know that ax squared plus bx plus c equals y. So my first coordinate point is negative 2, negative 4. So that a times negative 2 squared plus b times negative 2 plus c equals negative 4. My equation will be 2 squared is 4. 4a minus 2b plus c is negative 4. My second coordinate is 1, negative 1. So a times 1 squared plus b times 1 plus c equals negative 1, or a plus b plus c equals negative 1. So that's equation 2. Equation 3 is 3, negative 19. So a times 3 squared plus b times 3 plus c is negative 19, or 9a plus 3b plus c is negative 19. So that's my system. Now, from the system, I'm going to get a matrix 4, 1, 9, negative 2, 1, 3, 4, negative, whoops, I'm in the wrong place, 1, 1, 1, and then this should be a negative 4, a negative 1, and a negative 19. So make sure I've put it in correctly. 4, negative 2, 1, negative 4, 1, 1, 1, negative 1, 9, 3, 1, negative 19. So we're okay there. Now I'm going to put it in my calculator and RREF it. I already have it in my calculator. But if you don't remember, you do second matrix, and matrix is above x to the minus 1. And if you want to put it into your calculator, edit. It's a 3 by 4, 3 rows, 4 columns. So 4, type in the numbers, 1, negative 4, 1, 1, 1, negative 1, 9, 3, 1, negative 19, and then come back to the home screen, and now I need to do an RREF on that matrix. So if you don't have it in your calculator, remember, if it's in your calculator already, you can pull it down if you've done it for practice. But again, if not, it's second matrix. I now want to do math. Whoops, I want to do a determinant on that. Second matrix, math. Go down to RREF. And you want to do it on the matrix A. Second matrix A. Now that comes out in row reduced echelon form, so I can read it right off. So it's 1, 0, 0, negative 2, 0, 1, 0, so 0, 1, 0, negative 1, 0, 0, 1, 0, 0, 1, 2. So this is A, B, and C. So this says that A is negative 2, B is negative 1, and C is 2. Or we know that Y is AX squared plus BX plus C, or Y is A, which is negative 2, X squared, B, which is negative 1x, plus C, which is 2.